Day 781 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3699, number of zigzag arrays 1. The difficulty level is hard, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given three integers n, l, and r. A zigzag array of length n is defined as follows. Each element lies in the range L and R. No two adjacent elements are equal. No three consecutive elements form a strictly increasing or strictly decreasing sequence. Return the total number of valid zigzag arrays. Since the answer may be very large, return it in modulo 10th to the 9th power plus 7. A sequence is said to be strictly increasing if each element is strictly greater than its previous one, if exists, and a sequence is said to be strictly decreasing if each element is strictly smaller than its previous one, if exists. All right, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So, in example 1, we have our input n equals 3, l equals 4, r equals 5. The output is 2. Explanation says there are only two valid zigzag arrays of length n equals 3 using values in the range 4 and 5. So we could do 4, 5, 4 or 5, 4, 5, right? Though these are the only two valid zigzag arrays, and since there's two, we return 2. So let's break this down one step further. Since n equals 3, that means we need to have 3 elements in the array, right? In the range of 4 and 5. Now, since we only have 4 and 5 are consecutive numbers, meaning like 5 comes right after 4, that doesn't give us much of a range, right? So we're going to have to use these elements more than once. So one way we could form a zigzag of length n using these elements and all elements in between is we could do 4, 5, 4, or we could do 5, 4, 5, right? Those are the only two ways, being as though these numbers are already come right after each other, right? So the output would be 2. Now let's take a look at example 3 where we actually have a number in between L and R. So in example 3, we have our input n equals 3, L equals 1, R equals 2. The output is 10. That means there are 10 valid zigzag arrays of length n equals 3 using the range 1 and 3, right? So this time there's actually a 2 in between 1 and 3, so we have another number we can use as opposed to 4 and 5. There were no numbers in between. So these are the 10 different ways. We could do 1, 2, 1, 1, 3, 1, or 1, 3, 2. We could do 2, 1, 2, 2, 1, 3, 2, 3, 1, or 2, 3, 2. Or we could do 3, 1, 2. We could do 3, 1, 3, or we could do 3, 2, 3. These are all arrays meet the zigzag conditions, right? And there are 10 of them, so that's why the output is 10. Now, once again, remember, each element in this zigzag array, the 1 is less than 2, then 2 is, and then this one is less than 2, right? So it's nothing is strictly increasing, right? We can't do 1, 2, 3 because that's not a zigzag. We can't, you know what I'm saying? We can't do 3, 2, 1 because that's not a zigzag. Those would be strictly increasing or strictly decreasing, which is not allowed. It has to be a kind of like a peak and valley context from previous problems where this 1 would be a valley, then we need a peak, then we need another valley. Here, valley, peak, valley. Here, valley, peak, valley, because 2 is still less than 3, so it still counts as like a valley. Here, it'd be peak, valley, peak, right? Or peak, valley, peak. You see, because 2 is greater than 1, so 1 would be the valley, and since 3 is greater than 1 and 2 is greater than 1, 2 and 3 would be the peaks. So I hope that makes sense to y'all, and now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult at all. We're going to use some dynamic programming, so I hope you're excited about that. Now, since all of the numbers can become very large, we need to calculate modulo 10th to the 9th power plus 7, so we can handle that. Up here, we'll just say let mod equal 1 underscore 000 underscore 000 underscore 007. Boom. Then we need the number of distinct values available in the range of L and R. So we'll say let K equal R minus L plus 1. Sorry, y'all. Boom. Then we need the number of zigzag arrays ending at the value where the last comparison was an increase. So initially, arrays of length 1 can end at any value, so every position starts with a count of 1. So we'll declare a variable called up, set that equal to an array of integers. Sorry, y'all. Equal white space, put the parentheses. We're gonna say repeating colon 1 comma count colon K plus 1. Boom. Now we're going to do the same thing for the down zigzag. So the number of zigzag arrays ending at value V where the last comparison was a decrease instead of an increase. So this time we're going to declare a variable called down, and we'll set that equal to an array of integers. Come outside of that, open up the parentheses, repeating colon 1 comma count colon K plus 1. Boom. Now we need temporary arrays which will be used to build the next DP state. So we'll come underneath this, declare a variable called new up, and we'll set that equal to an array of integers, open up parentheses, we'll say repeating colon 0 comma count colon K plus 1. Come underneath that, declare a variable called new down. We'll set that equal to an array of integers. Come outside of that, open up the parentheses. We'll say repeating colon 0 comma count colon K plus 1 as well. Now we're going to build arrays from length 2 up to length n. So we'll come underneath this and we'll say for underscore n 2 dot n, sorry. We need to get the running prefix sum of down values to end with an up move at value V. Then the previous value must be smaller than V. So we need to create a variable called run down, set that equal to 0. Sorry, y'all, should only have 1D. Boom. Then we're going to start another for loop. We're going to say for V and 1 K will open up the brackets, and all smaller values are going to contribute. So we'll say new up square bracket V. We'll set that equal to run down. Boom. Then we're going to add the current down state into the running sum. So we're going to say run down equals, open up the parentheses, run down square bracket, plus down square bracket V. Come outside of square bracket and the parentheses, and we're going to say mod. Now the running suffix sum of up values to end with the down move at value V, the previous value must be greater than V. So we're going to do the same thing. We'll come underneath this for loop and we'll declare a variable called run up. So we got to run it up, you know what I'm saying? And we're going to say set that equal to 0, and we're going to say for V and stride, open up the parentheses, from colon K, comma, through colon 1, comma, by colon -1. Come outside of the parentheses, open up the brackets, and all larger values contribute. So we're going to say new down square bracket V. We'll set that equal to run up. Then we're going to add the current up state into the running sum by saying run up equals, open up the parentheses, run up plus up square bracket V. Come outside of that and we'll say mod. Boom. Now we're going to move to the next DP layer. So we'll come underneath this for loop right here, and we'll say up equals new up, and we'll say down equals new down. Boom. Then sum all valid arrays ending at every possible value. We come right here and we're going to declare a variable called result, set that equal to 0. Then we're going to say for v and 1 dot 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 k. We're going to open up the brackets and count arrays whose final comparison was an increase. So we're going to say result equals, open up the parentheses, result plus up square bracket v. Come outside of that, we'll say mod. Then we'll say result equals, open up the parentheses, result plus down square bracket v. Come outside of that, and we'll say mod. Then we need to return the total number of zigzag arrays by coming right here, and we're going to say return results, y'all. Boom, that should be all she wrote. Let's give it a run. Make sure it runs properly. Cannot find run up. This should be a lowercase p. Let's run it again. See if that did the trick. And it's accepted. So let's go ahead and submit it and make sure it's still accepted after we submit it. And look at that, y'all. 437 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So with that being said, y'all, make sure you get one more look at the code. This is the top part. This is the middle, or this is the middle. And then this is the rest of the code, y'all. So yeah, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.